Hello friends, it's been a long while since the last EdgeDB day, almost a year in fact. That year flew by fast because we've been quite busy with making EdgeDB 3.0, and it's a huge release, the biggest yet. It's so packed with new stuff that we have an unusual challenge of prioritizing what we can cover in this stream, what can go into the blog post, and what just has to stay in the changelog. But that's a good problem to have, right? Before we chat about new features, let's reflect on what happened with EdgeDB since the 2.0 release. We see thousands of monthly active users of our toolchain. Our Discord community almost tripled in size and now has over 1,800 members, and it's an amazing community to be part of, vibrant and caring. And members of our community regularly share anecdotes and stories about why they want to use EdgeDB. Some come to us because they love the power of our data model. Inheritance, access control, the flexibility of globals, the built-in migrations. Many choose HTTP because of HQL, our query language. Users tell us that after learning HQL, they often don't want to ever use any other query language. Some come to us because they're tired of ORM limitations and poor performance. They see a clear improvement with HTTP. We see users switching to HTTP from established products like Firebase simply because they want more powerful schema and querying, and HTTP delivers that. Most importantly, our users build apps and products with HTTP. Some of our users are individual developers who build hobby projects. Some are from small startups, but we have a few who build massive production systems with HTTP as well. All of them are important to us, and we are incredibly happy to receive a torrent of feedback and some healthy criticism from all of you. Our core mission, though, remains unchanged. We are passionate about meaningfully improving relational databases, making them friendlier, making them more powerful, unlocking their full potential. HTTP is way more than yet another database service or a new highly specialized storage. It's a very serious attempt at going beyond SQL in a way that not just enables one use case, sacrificing all the others, but actually be a better version all around. It's an attempt at improving upon slow and complex ORMs. It's a fresh take on how we write and maintain applications. It's an attempt to break the status quo. And we are incredibly passionate about that. Anyway, back to EdgeDB 3.0. By far, the most exciting thing about this release is that the entire feature set is inspired by you, our users. We have a lot to cover today, so let me summarize what's new so that we have a guiding line to follow. First, there is a big update with our schema declaration language that I just have to mention. We've replaced the arrow after property types and link targets with colons and made the link and property keywords optional in the majority of cases. This change lowers the learning curve a bit and brings our SDL closer in line to languages like TypeScript and Python. But there is an even more important reason for the change. The new syntax is going to lead us to exciting features in our type system in the future, such as composing types in your queries on the fly. So stay tuned for that. And of course, HTTP is fully backwards compatible, so if you like the old syntax, you can use it. By the way, you know that we have an RFC process. There is a repo in our GitHub org that you can use to find details about many of the 3.0 features, but moreover, you can even write an RFC yourself. Back on track, the next big feature is performance analysis of HQL. In the SQL world, we have explain. In the HQL world, we now have analyze, and we've built some beautiful tools for you to use it with. The next big feature is triggers and mutation rewrites. They can make your database react to your queries, do stuff like maintaining audit logs or rewriting your mutations. And then we have a new, completely revamped UI. And I personally think that the UI of EdgeDB 2.0 was already best in class, but wait until you see what we have for you in 3.0. There is a big and sort of unexpected surprise feature in this release as well. We've added read-only SQL support to HTTP. The reason is simple, really. SQL had a bit of a head start, and there is a lot of business intelligence tools that our users want to use with EdgeDB, and they only work with SQL. So there is a way now. Next, we're adding official clients for Java and Elixir. And when it comes to Java, it's more than just one language. It also includes the whole bunch: Kotlin, Scala, Clojure, and others. And of course, we didn't forget about adding new things to EdgeQL itself. We have splats. Select star in SQL. Splats are better and more powerful version of that. We add new set operators, nested modules like in Rust, a way to define abstract indexes, and also a way to configure what exact Postgres index you want to use. And I'm sure I forgot a bunch, since there is so many new things. Lastly, we're adding an OpenAI assisted chat to our documentation, and we just had to make sure that EdgeDB can power that. So we are adding pgvector support. You know what? I could continue with this for quite some time. But I have a better idea. Let's get the EdgeDB team explain in detail some of the new features. And for the rest, we have a new blog post. That's, of course, as usual, an epic must-read. Now, I'd like to pass the mic to Devon, our head of DevRel, to tell you about query performance analysis in EdgeDB 3.0. Hi, Devon. Excited to see you. Please take it away.
It's great to see you too, Yuri. Thanks everyone for joining us today for our EdgeDB 3.0 launch event. My name is Devon Campbell, and as Yuri said earlier, I'm the head of developer relations here at EdgeDB. That means my role is to make sure that you can be successful with EdgeDB. And I do that in a couple of different ways. First, by making sure that you have the resources you need, the documentation, the guides, and making sure you can get answers when you have questions. And second, by steering our development efforts to make sure that we're building out EdgeDB in a way that makes it easy for you to have that success. Today, I'm going to be showing you our new query performance analysis tool that we're shipping in EdgeDB 3.0. This is going to make it easy for you to optimize the performance of your EdgeQL queries. Okay, I've already got an EdgeDB CLI REPL open here. You're going to get to this just by running EdgeDB inside an EdgeDB project directory. Now, I have pre-written a query here that we can take a look at, and I'm going to walk you through what this query does really quick before we run it. This is a database of the Marvel Cinematic Universe, so lots of Marvel movies and characters. So first thing we're doing is we're selecting movie objects out of this database. We're going to get the title and release year properties of each of those movies. Then we will dig into the actors link and get the names of each of the actors attached to the movie. That's coming back here. And I'm going to use an aggregate function count to count the number of actors linked on this movie. That's going to be actors total. Then we're using a backlink to look at the franchise objects, and for any that link to this movie in the entries link, we're getting the name. There should only be one, and that's going to come back as franchise. Then we're using a similar backlink here, but instead of the name, we're getting the entries, so the other movies in the franchise, and we're using the aggregate count function to count those. That's going to come back as movies in franchise total. We're going to order all these movie objects by their titles. Now, let's run that and see what the results look like. Okay. Now, what if we want to understand how this query performs? The query performance analysis tool is going to let us do that. I'm going to pull that same query back up, and I'm going to drop this analyze keyword back, onto the front of the query. And that's going to invoke the query performance analysis. The output here is the original query I wrote, but with these annotations, these numbered bubbles, then if we look down here in the query plan, this is going to give us the actual performance metrics. And each row of this query plan is correlated back to a portion of the query that we wrote. The goal for this tool was to be easily readable, even if you're not a DBA. And part of that is being able to understand what parts of the performance metrics map onto which parts of the query. This CLI interface makes that really easy. But we have another interface that makes it even easier. I'm going to switch over to our EdgeDB UI, and I would do that just by typing the EdgeDB UI command inside the project. I've already done that, so I'm just going to switch over to the browser. This is what will open when you type that command. You'll get your default browser with our EdgeDB UI. Now we can see I'm in the MCU sandbox instance, and I'm going to click into the EdgeDB database inside that instance. Now, I could run this same query performance analysis inside our web REPL, and what that's going to do is that's going to show me a flame chart. I'll show you that a little bit later. But instead, I'm going to open the query editor, which gives us another option for visualizing this data. Let's paste the query back in. And I'll drop that analyze keyword back on the front. Okay. All right, now this is the flame chart I mentioned earlier. That's what you're going to see if you run this query performance analysis in the web REPL. But the default visualization inside the query editor is the area chart. And that's going to show you this series of boxes. Each of the boxes corresponds to a portion of the query we wrote. The size of the boxes is going to show you the impact of that portion of the query in terms of the metric you've selected. And you can select either time, in which we time out the query and the individual parts of it, or you can select cost, and that's a static analysis of the query. But going back to correlating this output back to the query you wrote, I want you to pay attention to what happens as I hover over each of these areas. You can see that it's highlighting the area as I hover over it, but also on the left in the original query, it's highlighting the portion of the query that's correlated to that area on the area visualization. This performance analysis tool and the visualizations that go along with it are going to serve as a foundation for you to improve the performance of the applications you're writing for your users. We're going to be iterating on this quickly, and we'd love to know what you would like to see here. So please join us on our Discord, where you can share that feedback about this feature or about any of the other features that you're seeing today and that we're launching in EdgeDB 3.0. You'll also be able to ask any questions that you have about those features, and we'd love to help you out there. We hope to see you there. Thanks, everyone, and back to you, Yuri.
Thank you so much, Darren. What's one of the most fundamental features of EdgeDB? I'd say that it provides consistent experience across multiple languages. You have a high-level data model that feels native to any modern programming language. You could use the same schema migrations flow and tooling regardless of what framework your app is using, and our client libraries are fast, advanced, and easy to use. Here is Scott to show you some cool things you can do with Python and TypeScript. Hi, Scott.
Thank you, Yuri, and hello, everyone. My name is Scott Tren, and I support the TypeScript libraries here at EdgeDB. Today we're going to talk about code generation and some interesting workflows that it makes available. So let's start here. Why generate code? Which is really, why not just use strings of EdgeQL? That's totally valid for some use cases. The flexibility of having a full query language means that you can often generate something truly dynamic and powerful. So why not do that all the time? For queries that are not runtime dynamic, in other words, if you're not building the query string itself differently, generating the function and types saves quite a bit of time. But the real value is that it produces far more maintainable code. Just like your schema, you now have a source of truth for some important shared business logic. Any changes to the schema or these queries will generate compile time feedback for what needs to be fixed across your codebase. You can use the same set of queries across multiple languages. We're actively working on ensuring that all of our supported languages have code generation capabilities. A cool little side benefit here is that since we use EdgeDB itself to understand your query, you actually get build time checking of the query itself for syntax errors and typos, which you don't get if you manually build a query string. All right, so here's our example app. It's a very cool weather app that allows you to input some places in a web UI and then see the current weather for those places. I know some of you are having a reaction to the date formatting. I'm truly sorry. I'm using locale-aware formatting and can't help that my locale is just wrong about date formats. So here's how we might model this domain. We have a place type that represents the name and coordinates of each place. And we have a reading type that represents a temperature reading for a place at a specific time. Now let's check out how we've structured the app. We have a Next.js app that handles displaying the UI and talking to the database to add places and look at temperature readings. And we have a backend service written in Python that gets a list of places defined in our database and pulls a weather API for the current temperature in each place. Note the highlighted files here. Each one contains a single EdgeQL query that the generator will turn into a function in our target language. Let's look at a very simple one, a query that lists the name and coordinates of all of our places. All right, easy enough. We select the place and its name and coordinates. Nice. Now let's run the Python generator. Note that I'm specifying a location to save the generated function. Since we're in a monorepo, we want to make sure that the functions are generated into the various services that want to call these functions. You can imagine a tool that automates this based on how your repo is structured, but for our purposes, we'll just run the command manually. And here's roughly what gets generated for this query. As a reminder, here on the left is the schema of our place type and the query that we saved as getPlaces.edgeQL. The generated types include the automatically generated ID field with a UUID type. It also produces a nice class for the name tuple. And then you can see it mapped our query into the body of the function. And here is a screenshot of VS Code showing me the type of the variable places that has been returned from our generated function. Likewise, for a query that takes some parameters, you get a nicely typed function with named arguments. And now let's do the same for TypeScript. Let's run the TypeScript generator from within our Next.js project. And there we go. We can use the same query in both Python and TypeScript, and we're able to get strongly typed functions that are always up to date with our schema. Since we have a little bit of time left here, let's also take a look at another generator available in TypeScript, the Query Builder. The Query Builder is a code-first way of writing EdgeQL queries. This query selects each place in the database and computes a link to the latest reading if any exists. We intentionally keep the Query Builder semantically as close to EdgeQL as possible too. You can see how it reads very similarly to the handwritten EdgeQL on the left. Another notable feature of the Query Builder is that we get back the ability to generate dynamic queries at runtime, but this time it's fully typed. You can use constructs like loops and conditionals and data structures to build up a dynamic query. We can also compose queries and save shapes. Here we're abstracting out the getPlaces part of the query. We've added a filter and an order by clause here. And the shape that describes the latest reading. And then composing a query that is getPlaces with latest reading. Composing the getPlaces query into this select means we get the ordering and filtering from the base query. This is cool because now we have one component that only cares about the places, and the main UI here also wants the latest reading that has the same filtering and ordering applied. I'm still polishing up this example code, but we'll be posting it to our examples repo on GitHub. It'll be named something like Next.js, Python, Weather, Monorepo, something like that. Thanks so much for your attention. I hope you enjoy the rest of the event. If you want to reach out, I'm always around the EdgeDB Discord. Back to you, Yuri.
Awesome. Thank you so much, Scott. Many companies that use EdgeDB and store a lot of data in it wish to use some of the existing business intelligence tools like Tableau, DataGrip, or Airbyte to visualize it. Or maybe just use pgdump to quickly export all of the data and back it up. With EdgeDB 3.0, you can now do just that. Please welcome Aljaž, member of our core database team, to tell you more. Hello, Aljaž.
Hello. Really nice to speak here at EdgeDB. I am here working on compilers and the core database team. And as Yuri said, I'm talking about SQL today. So the big news, as Yuri said already, is that with 3.0, EdgeDB now supports SQL. It has been a large request from our users, so we decided that we really need to add support for all the data tools that already exist. So it is read-only access. We have a lot of advanced features in EdgeDB like access policies that would be very hard to implement in SQL. And it supports Postgres via protocol. This means that EdgeDB can now connect with any application that is able to connect with Postgres. And this means a lot of tools. For example, just the core Postgres tools like PSQL and pgdump, and then DataGrip and dbeaver. For analytics, we tested Tableau, Cluvio, and Metabase, and for transfers, we tested Airbyte, Fivetran, Hivo, and Stitch. So, if you want to get started, just fire up a terminal and use the EdgeDB CLI here to get the credentials for your instance. Here I say EdgeDB instance credentials, instance name, and then use JSON flag to get the password in plain text. Then you can use these credentials with any tool. For example, I'm using PSQL here, and you just specify all the parameters. It should ask you for the password, and then you connect and get the SQL prompt. You can now issue any SQL command like select version, and you should get the result. Now, the big question here is, what can I query? Because as you know, Postgres has a different data model than EdgeDB. It has relational instead of graph relational that we have. And to actually answer how these two map between one another, I have to tell you how the data is stored in your EdgeDB instance. If you've seen our 1.0 talk about how EdgeDB works, you've probably seen a diagram that looks like this. At the beginning, here is the HQL query that comes to our server and is compiled from HQL to SQL. And this SQL is then passed to Postgres instance that runs underneath EdgeDB server. And the naive approach here would be to just say, okay, expose this Postgres instance and just allow users to connect to that. The problem here is that it contains machine-generated schema names and column names and table names, and it's not really human-friendly. So what we did is we created another compiler that takes nice, pretty user-friendly SQL and compiles to machine-friendly SQL. Note that these two SQL queries have the same structure, and this is because I'm going to tell you how EdgeDB actually stores data, how the tables are laid out, so you can know what SQL queries you can issue. Okay, this is how we store things. Object types are in tables. Every property is a column. Every link is an ID column. Multi-properties are a separate table with one-to-many relationship to the original object table. And link properties are columns in these separate tables. Inheritance is done via separate tables. This may be a lot, so let's go over it with examples. If I have a type content that has name and unit price, you can query this simply by saying select ID, name, unit price from content. First, note the uppercase name here. It is exactly the same as here, and in SQL you need I'm blanking. You need these characters here. And the second thing is note that we have ID here. Content does not specify ID, but it inherits ID from the object type. So you can also use the ID because it's inherited from the parent. And you can imagine that we created the database using this DDL command, just saying ID, UUID, not null, primary key, name is text, and unit price is numeric, not null. Okay, I've already hinted how inheritance works. When you're extending, say, movie that is extending content, and you specify additional columns in the new type, we create a new table. Well, not create, we expose a new table that would be created with this DDL command, and we populate it with all the columns from the parent, and then add the columns from the new type. Links are stored with just simple column ID. So here I have album that has an artist, and this is mapped to just the column that is UUID. And then you can join the original type with the new type, just saying join. This basically this is the standard SQL here. Multi-properties are a bit more complicated. When you have, say, invoice that has a multi-link items to content, we create two tables. The first one is the obvious one for the invoice. In this case, it just has the ID because invoice does not have any other properties. And then for the items, we create a separate table. And this table has source, which is an ID column that is pointing to the invoice, and target, which has the also UID that is pointing to content. Link properties here are mapped to columns in this link table. Okay, so now you can imagine that any EdgeDB schema can be mapped directly to normalized SQL schema. So I've created a demo from Chinook database, and I'll be using Metabase to connect to that database. You'll be probably met with form like this with any data tool that you open up, and you just have to input all the data that I've had before on the slide, saying your host name, port, database name. Make sure to use Postgres, of course, and use username, password, and enable SSL mode. And when you do that, you should be met with data that is in your database. Metabase here has a table view of the data, nothing special here. And you can also create questions in Metabase. Here you can see all the columns from my database, and this is because we emulate all the PG catalog information schema details that tools are expecting from a Postgres instance, so it automatically works with your schema. So I'm creating a question about invoices and saying I want to filter by billing country, and then I do a summary of invoice total by billing country and billing state. And this is the data. Yeah, so that's it. In summary, EdgeDB can now work with any SQL tool. Thank you.
This is great, Aljaž. Thank you so much. EdgeDB has an amazing data model and a lot of useful primitives in it to build applications with. In your schema, for example, you can define abstract types, and you can then inherit your types from multiple of them, designing reusable schema this way. You can define functions, access policies, global variables to store and access your session state. And of course, you can define indexes and constraints. But one thing was missing before EdgeDB 3.0, and that's of course triggers. Here's Sally, head of our core database team, to tell you all about them. Good to see you, Sally.
Hey, Yuri. I wouldn't say triggers are the only thing missing, but it sure was a big one. So like Yuri said, I'll be talking about two new features, triggers and rewrites. These are pretty closely related features, and in many systems, they would be merged together as triggers, but we think they're different. Let me explain why. So in our system, we're providing two things. One is triggers, which run a query after an object is modified. You do an insert or an update or a delete, and you can provide triggers that process those and go do follow-up actions. And then we have rewrites doing a different thing, which is changing a modification before it happens. So when you do an insert or an update, a rewrite runs first and alters what actually happens. And so I'll run through some examples of EdgeDB triggers and rewrites and let you see for yourself. So the most basic example of a trigger and a pretty common use case is simply building an audit log, logging actions that happen in your database. So here we have a person type, and obviously in a real application it would have many more fields. But we declare a trigger here that we call log insert that's declared to run after each insert. And for each element inserted, it runs the body of this, which here is inserting an element into a log type that logs we've done an insert, and here's the name of the person we've inserted. Of course, you can't, it's not just inserts, you can also trigger on updates. So here we have an update where we log the old name of an object and then the new name that it's been changed to. Obviously, in a real situation, you would probably want to store this in a more structured way, but this is good for an example. Of course, you can also put triggers on deletes. So doing these audit logs are a pretty common use case, but there are other options or other possibilities too. One is to implement complex multi-object constraints that help you enforce invariants that normal constraints can't because they aren't local, because they span multiple objects in a database. So here we have an account type, and we imagine that it has a multi-link to a transaction object. And we figure each transaction object has got some amount associated with it, which is positive for a debit and negative for a credit. And we want to make sure that we haven't overspent our account. So we can, as part of that, we could create this trigger on account that runs after every insert and update and asserts, which is another new 3.0 feature, that the sum of the amounts of each transaction is greater than or equal to 0. And this is something that couldn't have been done with pure constraints as they exist now. This isn't the whole story. In order for this to work in this case, you also need to account for the case where transactions themselves get updated, which could be done either by making amount read-only or by putting triggers on transactions as well. Triggers have a number of other cool things that can be done, including for all, which allows you to have a trigger that looks at everything that's changed on a type at once. So moving on past triggers towards their first cousin, mutation rewrites. Here we have the sort of hello world of mutation rewrites, which is maintaining a last modified time on a type. So here we have a modified property with the datetime type, so nothing special there. But we declare a rewrite rule on it that says every time the post is either inserted or updated, rewrite the modified value using datetime of statement. So this means that every time post is updated, modified will be set to the datetime. Now, it would be a little tedious to have to put this on every object in your database that you care about a modification time of. And so fortunately, EdgeDB continues with its long tradition of using multiple inheritance and an object model to enable mix-ins and code reuse. So here we can declare an abstract type with mod time that has that modified property and the rewrite rule. And types like post or anything else can simply extend it and have mixed in a modified type, modified property with the rewrite. Now, of course, these are called rewrites, and so far I've only shown you, I guess, overwrites. So rewrites can, of course, also legitimately rewrite the value. So here we have a slug property on a post, and perhaps we have a rule that our slugs are always lowercase. So then we can actually enforce that and cause that to happen in the rewrite layer. We can provide a rewrite rule saying convert the provided slug to lowercase. And now we don't need to worry about it. Now, of course, if we had this rule, we could also set a constraint, but perhaps we have legacy endpoints that that are providing uppercase slugs, and we want to transparently support them. This lets us do that. Another great use of rewrites are that it can be used to create cached computeds. So for example, maybe a user type has a friends link, and we want to be able to quickly query how many friends they have. Well, counting in database systems can be slow because of underlying concurrency issues. And so we might want to cache that. So here we can automatically make a cached computed. Whenever user is updated, num friends will be updated to store the count. And so it can be accessed easily. Now, I haven't gone over everything. Dunder old can be used in mutation rewrites to give access to the previous values, much like it could be in triggers. Dunder specified exposes which values were present as a named tuple, which lets you do things like when you give a modified time, if you've specified it explicitly, use that one, otherwise set it to the current one. And then I guess this is going back to triggers, but for all on a trigger runs the trigger on all of the changes simultaneously. Now, how is this implemented? Well, as my colleague Aljas talked about earlier, we are built on top of Postgres. We have a compiler from EdgeQL to PostgreSQL, and that's how we implement our backend layer. Now, despite that, we do not actually use Postgres triggers. This is for a couple of reasons. One, we found they were kind of slow. And two, it's difficult using triggers to see everything you need to. We want our triggers and our rewrites to see the old objects and the new objects, including parts of them that might not be stored in the same table, such as multi-links. And so we implement it by injecting the appropriate trigger code ourselves after every mutation query. This allows us to see the complete before and after state pretty easily. Rewrites are similar, but a little simpler. We simply modify the generated code before doing the inserts or updates. So we figure out what the user specified, then we run the rewrites to see how they've been overridden, then we actually do the inserts. I hope you all find great things to do with both triggers and rewrites. I'm looking forward to hearing about it. With that, back to you, Yuri.
Thank you so much, Sally. If you ask me for my personal and 100% honest opinion, I will still say that EdgeDB UI is best in class. It's built in, it's always there for you, it's powerful and beautiful. You can browse your schema, work with the data, test your SQL queries, but you know what? We improved it greatly in EdgeDB 3.0, and it's even better now. Please welcome Diana, member of our UI team, to tell you more. Hello, Diana.
Hello, my name is Diana and I'm part of the UI team. Today I'm going to walk you through the most important and also most exciting things we did in the UI in the new release. So here in my terminal you can see I created two very simple projects, one with version 2 and one with version 3. And I opened UIs of both of them in my browser. So the biggest change we did in the UI is related to this REPL window. The old REPL window was trying really hard to implement two different functionalities, the REPL and the IDE. So for example, if you usually use REPL if you want to explore your DBs and quickly write one-of-time queries. Let's write some query, maybe select the movie and run it. And here you will see the output. Now, if you want to check something else, you write another query and so on and so on. But what if you want to update this query? Or you are not sure what the structure of it should be finally, and you just want to explore it more? Then, in that case, usually something like an editor would be more convenient. And this is possible in the old UI with this persist query checkbox here. Now, if you write the same query, maybe we can update it a little bit. Actors, they have name, and if we run it, you will see that the query is persisted in the editor here. So now you can update it as many times as you want. But I'm sure that you would agree with me that switching between these two modes in this way is a little bit confusing and doesn't feel a lot of fun. That's why we decided to redesign the whole thing. In the new UI, we have REPL and editor as separate windows. So let's explore firstly the REPL one. The new REPL web experience is very similar to the typical CLI flow, where you can write different queries. And for example, let's write a similar query we wrote previously. When we run it, you will see the result and the output here. If the output have many rows, usually we will only show you first few, and there is this show more button that will reveal the whole output. Someone can argue that the new REPL, web REPL is even better than the CLI one because we also have these two buttons here. With copy button, you can copy the whole output or only some parts of it as a JSON and use it somewhere else. And the view button is maybe not very useful in this typical use case. But for example, if there are properties with very long values, for example, very long strings or JSONs or even bytes, these values will be truncated here in the output, and you will be able to see the whole value only if you open view panel here. Of course, it is possible to navigate through the REPL history with command key and arrows if you're using Mac, or control plus arrows if you're using Windows. And of course, there is also help command. If you run it, it will give you additional commands that you can use in a web REPL. So for example, these introspection ones are interesting because with them you can explore the structure and data types that you have in your databases. So for example, this LT command will give you all object data types that you have in your schema. So we see here account, content, movie, person. If we go to the schema, we can see in both parts of the windows that indeed we have these object data types. So let's move now to the editor. As I mentioned earlier, editor is amazing if you need to write more complex queries, and it also has autocomplete. So for example, let's check the person type. It has, we want name, and also we want filmography, and from there we want title. And when we run it, we will get the output in the right half of the window. And there are also available the copy and view buttons with the same functionality as in REPL. As Devon mentioned, it is possible to write this analyze keyword before the query, and when you run it, instead of the output, you will get the graphical representation of the query, which can give you more insight into how expensive your query is or how much time was needed to get a result. The analyze is also available in the REPL. Of course, we persist all these queries in the history, and you can get a history on this button in the bottom left corner. We only have now these two queries, but you can search the whole history, you can load old queries, update them, edit them, and run them anytime in the future if you need it. The next big thing that wasn't available in version 2 is Query Builder. And this is actually yet another way to write queries, but I would say that it's especially useful for newcomers and everyone who is still not very comfortable with SQL. because it gives you this opportunity to build your queries by checking the checkboxes and providing, for example, providing the values of different clauses and modifiers that are available in HQL. So yeah. And of course, the builder queries are also saved in the history. The last thing I want to show you today is the client settings panel. When it is expanded, it will show you all configuration options that are available and all globals that are set in your schema. So for example, you can change globals and configurations. For example, you can allow or disallow access policies. You can check the business logic of your application and more. So make sure to check it. That would be everything from me today. I hope you enjoyed and that you will have a lot of fun exploring our new UI. Back to you, Yuri.
Thank you so much, Diana. We want to make sure that EdgeDB is ready for whatever use case you have. And one of the most popular feature requests recently was one to add support for a vector type. We understand. Today, supporting, storing, and efficient operations in vector data is crucial. Here's Victor, member of our core database team, to tell you how to do just that with EdgeDB. Hi, Victor. Good to see you.
Hi. Thanks for the introduction, Yuri. And hello, everyone. I'm Victor Petrovic, and I would like to tell you about our pgvector extension package. Everything started with us wanting to use the power of OpenAI and ChatGPT to make EdgeDB docs easier to search. OpenAI tools work by first converting text into these things called embeddings. These are sequences of numbers that represent the meaning of the original text. Embeddings are basically large vectors. Once you have these embeddings instead of text, it is much simpler to compare them using math. This comes in handy for things like search or even ChatGPT functionality. It's possible to store and manipulate these embeddings in Postgres thanks to the pgvector extension. So while our great UI team was busy working on this AI search functionality, we realized that we want to adapt pgvector extension for EdgeDB. So what is pgvector and what can it do? This open source Postgres extension can perform vector similarity searches. Basically, that means it provides the ability to compute Euclidean distance, cosine distance, and inner product for some pretty large vectors. And that's the functionality we needed to expose in EdgeDB. Our extension introduces the vector type itself, of course. It also provides several functions to perform the previously mentioned vector operations, various distance computation. And finally, it has indexes that help speeding things up for certain vector queries. How to use it? Here I'm going to show a simplified version of the schema that we made for our improved search functionality. First, we declare that we're going to be using pgvector extension. Now, after this, we will have the contents of this extension available at the ext pgvector module. Then we create our embedding type by extending ext pgvector vector type and specifying 1536 as the size, and that's just the size of the embedding that OpenAI uses. Finally, we create a document to store the actual document contents together with the embedding. You can find many tutorials that will teach you how to get embeddings from your text. That part doesn't change much across different applications. Populating the database with these embeddings is also pretty straightforward. But once you're done with all that, it's finally time to write a search query. In our query here, we have a couple of parameters. The query embedding is the embedding corresponding to the search query, and there is also the similarity threshold for results. Similarity search uses cosine distance to compare the query embedding to the document's embedding. The smaller the distance, the greater the similarity between the document and the query. So we add this cosine distance as a computed value to our results, and then we use it to filter the results so that only the relevant things show up in our search based on the threshold, as well as we order the results by this distance in order of relevance. The search query can become sluggish if we have a lot of documents. So we can add an index that specifically speeds up cosine distance operations. It's worth noting, though, that pgvector indexes enable approximate nearest neighbor search. This means that you trade accuracy for speed. Unlike with most indexes, you should expect to see a slight difference between the results that you had before and after adding one of these approximate indexes. Query performance optimization can be a very fiddly process, and EdgeDB Analyze tools are here to help with that. Devin earlier covered these tools in an earlier presentation. These tools break down what the query is actually doing and whether or not any indexes are in fact being used to speed things up. All kinds of invaluable information is there that's useful for trying out just all kinds of different optimizations. That's it for the overview on the pgvector extension. I hope that many of you will find it useful in this age of AI just as we did. Thanks for listening, and back to you, Yuri.
Thank you so much, Victor. That was great. We have a pretty tall list of requirements for our client libraries. They have to take the full advantage of our network protocol to be fast. They have to automatically recover from transaction and network errors, and they have to automatically maintain the client-side connection pool for you, and a myriad of other things. Building a new EdgeDB client is not an easy task, but once done, you can have an amazing database experience with it. EdgeDB already has support for many languages like TypeScript, Python, Go, Dart, .NET, and Rust. And today, we're announcing support for Java and Elixir. Here is Quinn, member of our tools team, to tell you more about the new Java binding. Hi, Quinn.
Hi, Yuri. Hey, everyone. Today I'll be talking about the Java binding. So let's quickly go over what our goals were with this binding. We wanted to create an asynchronous API usable from both vanilla Java as well as third-party asynchronous frameworks like Project Reactor. We also wanted this API to be available to other JVM languages out of the box. So how do we go about building a new binding? We have some predefined APIs and behaviors we'd like to share across all our bindings. For example, error names, our connection parameters, and our transaction and retriable connection behavior. To achieve this, we have some shared client test cases we implement to make sure all these features are working correctly. We also have some philosophy when it comes to creating new clients. We want to provide the thinnest possible abstraction between your code and EdgeDB. We also want this to be as performant as possible. EdgeDB implements its own protocol to achieve this. We want a simple API surface. We don't want to bloat you with a bunch of different methods and classes. We provide everything under one entry point called the EdgeDB client. We want to expose implicit transaction retries and connection retries. In case there's a network blip, you don't have to worry about losing your data. We also implement automatic client pooling so you can run your queries concurrently. So let's quickly talk about the client agnostic query tests. We recently implemented new tests to our shared client test case that tests our deserialization pipeline called Codex. There's a few challenges we had to overcome when writing these tests. We needed a way to format the test definition to include both type information and the result, so bindings can insert the correct path was used to deserialize the result. To achieve this, we encode type information into the actual result object, so bindings can insert both the type and the actual value itself. But can we automate this test generation? There's hundreds of thousands different combinations of different types, each with their own grammatical rules. We can take advantage of EdgeDB's introspection API to figure out where the puzzle pieces fit and compose queries and values together to form different tests. We can then generate all possible combinations of these types and values up to a certain point, and then write them to a test definition file for other bindings to consume and test against. Currently, our .NET binding and our Java binding are the only ones implementing these tests, but shortly we'll be expanding this to the rest of our bindings. Let's go back to Java. So Java exposes everything you'll ever need under the one class, the EdgeDB client class. This class has the same zero argument constructor as the rest of our bindings, automatically resolving the connection arguments via projects. We can call the query method on this class to execute an EdgeQL query, specifying the result type of the query and the query itself. We can also model our data as classes. We annotate the type with the EdgeDB type annotation, and then pass it to the query method to tell the binding to deserialize the result as that class. And of course, all of this is available to Kotlin and Scala and the rest of the JVM languages out of the box. We also support polymorphism. We can represent abstract types in the schema as abstract types in code. And the same works for when you query it. You can specify the class as what you want as the result to be, and you can specify a query that selects out the abstract type, and then use the instance of keyword to check against the result. The binding will automatically discover subtypes of the class you pass in and deserialize to those subtypes. Thank you, everyone. As always, please make sure to read the documentation and report any issues you find on our GitHub. Thank you.
This is great, Quinn. Thank you so much. This wraps up the feature highlights of EdgeDB 3.0. There is just one more thing though, EdgeDB Cloud. Let me tease you with a few details. We're designing our cloud to have just as good DX as EdgeDB itself, tightly integrated in client libraries, in our tooling, be as zero configurable as possible, have great UI and great DX, and eventually have solid integrations with the services you use every day, like GitHub, Vercel, and Netlify. To tell you more, please welcome our co-founder and CTO, Elvis. Elvis, excited to see you. Please show us the cloud.
Thank you, Yuri. Hello, everybody. So, EdgeDB Cloud. It's a big deal and a major milestone for us. It's a project we've been working on for a while now, and we're super excited to share some details with you today. Our users love how seamless and easy it is to work with EdgeDB when developing locally, and our goal is to bring this experience to the cloud. Cloud instances look and feel almost like local instances, but they're available from anywhere. There's no need to fiddle with connection strings or complex configuration. Things just work. Let me show you a quick demo of what we're building. So here I am at cloud.edgedb.com, and I click on this sign up with GitHub button. Normally I would be presented with a GitHub authentication window, but I've created this instance prior to the demo to gather some metrics data so the charts can show up properly. So I have only one instance here called demo. So let's go ahead and click on it. That brings up the expanded view of the instance with vital metrics like the query volume, the number of active connections, storage and data transfer use. And this also is a screen where I can manage my secret keys. And secret keys are like API tokens. You use them to authenticate to connect to your instance from anywhere securely. So let's say we want to create a production secret key. We don't specify an expiry time. We don't want this to expire. We could also specify which instance this key gives instance to, not just this particular instance, but all instances or a specific list of instances. Or we can also limit which databases and or roles can be used in that connection. So we click a create key and boom, we have a new secret key. I'm gonna copy it now and I'm supposed to copy and paste it into the secret store of the application development platform where I'm deploying my application to, such as Vercel or something like that. Close that. But of course, the most interesting part about this web console is the list of databases here. When I click on the database, or example database here, I'm presented with the same UI I get when I develop locally. So all the great features of the web UI are available. I have my REPL, where I can work on my queries, just run some ad hoc quick queries. I have my query editor. When I iterate on my queries, I can design them, look at results. I have my query history right here, and all of the other features that are available in the query builder. I have my schema. I can navigate schema nicely in a graphical way or as text. I can search through it. And of course, I have the data explorer, which shows nicely, which I can use to browse my data nicely and can drill down, explore my data in different ways. It's all very, very, very nice. And of course, the web UI is not the only way you can interact with EdgeDB Cloud. All of this is natively integrated into our terminal, into our CLI. So you can create, destroy, upgrade instances, connect to them, work with them just like you do with your local instances. There is practically no difference in workflow. All right, so that's pretty much concludes this quick demo of EdgeDB Cloud. And on that, back to you, Yuri.
All right, this was great, Elvis. We all can't wait until we can build with it. EdgeDB Cloud is in private beta now. You can join it by asking for early access on our Discord or by joining the waitlist on our website. We want the cloud to be generally available to everybody in a few months. Besides that, there is so much new stuff that we just didn't have time to properly cover on this stream. So be sure to check out the announcement blog post and please spread the word about EdgeDB 3.0 everywhere you can. We need your support and we are counting on it. Thank you so much and see you soon again.